Hey everyone, welcome back to the Anshul course. So today we are solving problem 6 of the NeetCode 250 series, that is group anagrams. So let's read out the problem. We are given an array of strings, and what we have to do is group all anagrams together into sublist, and you can also return the output in any order. So now what exactly is an anagram? So it is a string that contains the exact same characters as another string, but the order of the characters can be different. So it means that two words contain the exact same characters with the same frequency, but the order can be different. For example, egg and cat, they both are anagrams because in both of them we have one A, one C, and one T, right? Similarly, we can see in this example pods, tops, and stop. These three are anagrams of each other. So it is all because we have one P, one O, one T, and one S in all three words, right? So let's walk through the example first. First, we can see act and cat. They both are anagrams. In the second, pods, tops, and stop. They both are anagrams. In the hat, it does not have any anagram. So our output will become hat and cat will be one list. Stop, post, and tops. This will be grouped together in one list. But the order does not matter. So in the second example, we have X. So it does not have an anagram. So we will return X. Similarly, in the third, it is empty. So we will return empty string. So let's talk about the brute force approach. Now let's think about the solution. So we can have one way, like we take every string and compare it with every other string to check whether they are anagrams or not. So let's take the example. We have egg, cat, stop, pods, and tops, and hat. This is our example. So what we're gonna do is we can compare it with cat, with stop, with pods, with tops, and hat, and we can see if they're anagrams, then we can group them together. And for the second word, cat, we can do compare it with stop, pods, tops, and hat. Exactly for the third word, we will compare it with pods, then tops, then hat. Similarly, we can do it for each and every word. So what is happening is wrong here is we are doing so many of comparison, right? So the time complexity will become equals to n square k log k, where n is number of strings and k equals to length of each string. So for bigger inputs, this is not efficient. So we need something better. Let's think about something optimized. So if two, like for example, we had our example at cat, stop, pods, tops, and hat. This was our example. So if we have like two strings that are anagrams, right? That are anagrams, we can sort them and they can become identical. Let's say for act and cat, act, if we will sort this will become act, and for cat, if we sort them, this will also become act. So this will produce the same sorted string. So instead of comparing every pair manually, we can use the sorted string as a queue. Okay, so now for this, we will use an ordered map in which we will use a key and value pair. So in key, we will use the sorted string, right? And in the value, what we're gonna store is the original string, that is act and cat, right? So whenever multiple strings generate the same sorted key, they automatically go into the same group. So the core idea of the problem is to first sort the string, and then for sorting groups, we can just store the strings originally. So now we know the basic key idea of the problem, how we're going to solve this. So let's do a step-by-step approach. First, we will create a hash map in which key is sorted string and the value is list of anagrams, right? In second step, traverse every string, and for each string, what we're gonna do is make a copy, then sort the copy, then we will use sorted string as a key. Okay, then we will push the original string in the hash map. Okay, for dry run, in example, add in cat. So what we're gonna do is first make a copy, right? So let's make a copy of act. Then we will sort the copy. Then what we're gonna do is key value. At the key value, we're gonna push the copy because now it is sorted. In what value we're gonna push the original, that is act. Okay, this is how we're gonna do. So after processing all string, the hash map will contain all grouped anagrams. And then we can finally traverse the hash map and push all values in the answer vector. So, and then we can return it. Let's understand the code line by line. We have created a function group anagrams in which we have taken input of strings and this will return grouped anagrams. So we have first created a hash map in which the key value is a sorted string and the value is vector of all matching anagrams. So next we have traversed in strings in the input array. For this we will create a copy and then we do not want to modify the original string because later we're gonna store this one. So we will sort the temporary, that is the copied string. So this sorted string becomes the identifier for all anagrams. Like for example, for cat it becomes act, and for act it also becomes act because it is already sorted. So in this line, we insert the original string into the hash map using the sorted string as a key. So all anagrams go into the same bucket automatically. We do not have to worry like which one is going where. So it will do the calculation for us. And now the hash map contains all grouped anagrams for for the pods, stop, and tops. We have OPST. This is the sorted string for all these three words. So we will just do OPST in key, and in value we have pods, stop, and tops. Okay, and similarly for the act we have act and cat, and for head we will have head only, nothing other than this. So this is our hash map. This is how we are gonna create this. Next we have created a vector strings. So this is just to push back the values that we have in the hash map to return the final group anagrams. Let's talk about the time complexity. So sorting takes order of k log k, right, in which k is string length. Now when we do this for n strings, it will become order of n cross k log k because we have n number of strings, right? What is the space complexity? Is order of n cross k because this is the type of hash map we will be requiring to store a key value pairs. So basically this is much better than the brute force solution. Let's do a quick recap. What we have done, if two strings are anagrams, we store the sorted one, okay, and we use the sorted string as a hash map key, hash map key, and then we have grouped all matching strings in value. Okay, and then we have returned the values of hash map. Okay, so this is important hashing pattern. Definitely you should practice this. And if you enjoyed this explanation and found it helpful, then make sure to like the video and subscribe to the channel, because we are solving the complete NeetCode 250 series step by step. If you want, you can also comment which problem you want next. I'll see you in the next one. Till then, happy coding.